An exponential function is one where the variable, so our x, is in the exponent. So that is something in the form, a number to the power x, and this number has to be positive. Has to be a positive number that's raised to all the different powers. So for example, shall we consider the function 10 to the power x? So that means that for every x I have to raise 10 to that number, and shall we say, let's just look at it now for numbers between 0 and 4. So this is the domain of the function here. So 0 maps to 10 to the power 0, which is 1. Any number to the power 0 is 1. 1 maps to 10 to the power 1, which is 10. 2 maps to 10 to the power 2, which is 100. 3 maps 10 to the power 3, which is 1000. Finally, 4 maps to 10 to the power 4, which is 10,000. Of course, any number in between, so 1.5, 1.57, etc., etc., those are also valid. I'm just doing these nice round numbers for now. Okay, so here we go. So here we've got our x's, our inputs, 1, 2, 3, 4. And our y-axis, this is the function. This is going all the way up to 10,000. So this would be 5,000. So 0 maps to, well, let's start at this end in fact. So 4 maps to 10,000. Do some green. 3 maps to 1,000 all the way down here. 2 maps to 100. Almost 10. I'm sure that's, yeah, something like that. 10, 1. So this is 0 is a 1. So it's got a shape like this. And so if we were to carry on with our x's below 0, then it would carry on getting closer and closer to 0. So you could say it tends towards 0, but never reaches 0. So this is something called an, let's not worry about that, it's called an asymptote, but let's not worry about that. Okay, so we've got a curve, and then it's tending towards 0, but it's never going to reach 0. But in fact, the function for our domain is just between here and here. So let's try another exponential function. So how about e to the power x? So here, this is the number e, remember? So that means that for every x we have to raise e to that power, and again let's do that for numbers between 0 and 4. So 0 is e to the power 0, which is 1. 1 gives us e to the power 1, which is about 2.718. 2 gives us e squared, which is about 7.388. 3 gives us e cubed, which is about 20.079. And 4 gives us e to the power 4, which is 54.576. So let's draw these. So again, 1, 2, 3, 4. This is x, this is our function. Now here, this is spanning over a much smaller amount of numbers. So if we put 50 here, 10, 20, 30, 40. starting at 4, so this is 54, so that's like here somewhere. 3 e to the power 3 is 20, that's about here. So you see there's these enormous differences once we get going. 2 gives us 7, maybe here. So something like that. And we have this same idea. So here's for the domain we're looking at. Then if we think about this function more generally, this one too along here. So this is also true over here. So they tend towards 0, but never reach 0. So those are a couple of different exponential functions. And so here with a positive exponent, we can think of this as exponential growth.